Okay, welcome to the third of this year's Science Council British Science Week Lunch and Learn series. Thank you for joining us. My name is Adam Donnan. I'm the Chief Executive of the Institution of Environmental Sciences, which is one of the member bodies that make up the Science Council. Attendees should add any questions that they have for the speaker to the Q&A function. And you can also use the chat function, which is available at the bottom of your screen for general comments. We'll be leaving about 10 minutes at the end for questions from the audience. Firstly, Carolyn, if you could go to your next slide. Firstly, a little bit of background on the Science Council, who are hosting this series of webinars. The Science Council is an organisation that I'm very fond of, as I served on their Board of Trustees from 2017 to 2024 and was their chair from 2021 until last September when my term in office ended. The Science Council was founded by a group of scientific professional bodies that came together to gain a royal charter to award Chartered Scientist a cross-science professional registration. Subsequently, they added 3 more designations: Registered Scientist and Registered Science Technician and Chartered Science Teacher. But the organisation is not just a registration authority. It also works to create a diverse and growing science profession that is trusted, respected, innovative, and equipped to meet regional, national, and global challenges. Next slide. This slide gives you an idea of the incredible diversity of the Science Council members and the disciplines that they represent. This is where the strength of the organisation lies, in being a genuinely pan-scientific organisation that I think is fairly unique in the landscape. Next slide. And you'll see the qualifications that I mentioned on the screen there. And the Science Council is committed to professional recognition of the diverse range of people working in the myriad of roles across the breadth of scientific disciplines and applications that it represents. We believe that by raising standards of practice and encouraging innovation, professional registration benefits the individual, their employer, and society. Science Council sets the standard for 4 interdisciplinary professional registers, which recognise workplace competencies and encourage career-long professional development and ethical, sustainable professional practice. Registrants demonstrate commitment and competence and agree to follow a code of professional conduct. We're particularly interested in vocational routes into the science workforce, such as T-levels and apprenticeships, and we're grateful for grants from the Gatsby Charitable Foundation, which helps support this work. For example, in a project that I was proud to chair, we have mapped over 30 apprenticeships to our professional registers, and we're able to offer shortened application routes for professional registration after completing one of those mapped apprenticeships. Next slide, please. Science Council also works with employers, policymakers, and other organisations that shape and deliver the education and training landscape for the science workforce, and other organisations that focus on science and the scientific workforce. We pursue high-quality workplace learning to support scientific excellence and innovation, and the recruitment and retention of the workforce that our nations need. This image shows logos of Science Council employee champions. These are just a handful of the organisations that the Science Council collaborates with. Next slide. This is the third of 4 events that has been run by the Science Council this week. All of the events are shown there on the slide. Can I give a personal recommendation for Monday's event from Julie Hill, MBE, and Professor Gary Cass, which I also hosted on Beyond Boundaries, Interdisciplinary Insights from Environmental Science. Obviously, the event has already happened, but it will be going up on the Science Council YouTube channel next week, so you can catch up with anything that you have missed. Next slide. So I'm now going to introduce our speaker for today. Professor Carolyn Roberts is an independent water and environment consultant and the Thames Warden of the Worshipful Company of Water Conservators. She was formerly the Frank Jackson Professor of the Environment at Gresham College from 2014 to 2018 and Director at the University of Oxford's Environmental Sustainability Knowledge Transfer Network. Previously, she was co-director of the Centre for Active Learning at the University of Gloucestershire and head of their School of Environment. She's also vice president of my organisation and formerly chair. And recently, she's been working on a legal case relating to water quality in rivers. So you may have seen her on the news recently. But alongside that work, for more than 25 years, Carolyn has been helping the police when bodies are lost or found in rivers and canals. And that is going to be the theme of today's talk. So over to you, Carolyn.
Thank you very much, Adam, and good afternoon, everybody. I'm looking forward to giving this talk, and I'm just since I can't see everybody here, I'm speculating in my mind how many people are actually taking notes on how to get rid of a body in a river, perhaps. Okay, so what this talk is really going to be about is how do we find out what might have happened, which is a very basic science question, actually, but I'm going to be talking about it particularly, but not exclusively, in the context of murder inquiries, and we'll come to that in a second. What I do has been christened by others as forensic hydrology, which I just want to echo what Adam said about the lecture on Monday. This is about the integration of scientific knowledge from a whole raft of different sciences, some of which are listed there, and it has an intersection with legal knowledge in the case of murder inquiries, and financial knowledge too, because obviously the police don't have unlimited resources, and they have to keep track of how much is being spent on different investigations. And certainly some of the other investigations, the non-police investigations or the non-police explorations with which I've been involved, require you to keep a very tight leash, if you like, on expenditure. So I said this was going to be about establishing what might have happened in the case of a murder, but I want to take you back a very long time, not quite the Stone Age, but this is the beginning of my academic career, when I was looking at what happens to rivers below urban areas. Now, many of you will be familiar with the idea that if you build an urban area, usually you increase the flow of water into a river because you put drains in and areas of concrete and roofs and so on. And what often happens, as you can see on these pictures here, is you get a lot of erosion in the river. But it's surprisingly difficult to establish the amount of erosion that's happened. So these pictures, some of them are very extreme, obviously. They're taken in various places around Britain. And so we need a way of establishing what might have happened in a more quantitative fashion. Now, when I first started doing this research, I used something called an ergodic hypothesis. This is certainly something perhaps not to drop into your pub conversation, but it's the idea that we can make an estimate of what might have happened by comparing an urban river channel with a very similar rural river channel, so a river that hasn't, to our knowledge, been affected by the growth of the urban area. And what you see on the graph here is shows on the x-axis along the bottom the drainage area of a river, the amount of land that's draining into it, and then if you just take the top set of lines, I'm looking at the cross-sectional area of the channel. Now, if you look at the open circles on there, you'll see that they're labeled rural sections. So these are river channel cross sections that I surveyed, and you can see generally that they increase in size as the drainage area increases. That's not unexpected. There's a logarithmic scale on both of these axes, but we'll leave that for now. So we can see that rural channels, roughly speaking, there's an equation there. The one that starts off y is 0.506x and so on, that describes that relationship. And then if we look at the black dots on the graph, this is it below the English new town of Skelmersdale in Lancashire, you can see those sites, those cross sections are much larger for the equivalent drainage area. Now, we can then perhaps make an assumption about the amount of erosion that's taken place in that urban river. But it's a pretty primitive way of estimating. And in fact, when I was starting this research, I started to develop a better model, if you like, of the cross-sectional area size which we might have expected, based not only on the drainage area of the river, but also on a whole lot of other factors, which I won't bore you with, but things like the nature of the geology and the rainfall intensity in the area and the shape of the catchment and so on. So on this diagram here, you can see that the River Tord, which is the one that goes through Skelmersdale, you can see a better prediction of the size of the cross sections, and then you get a better idea of the amount of enlargement that's actually happened to these channels, or this channel, by comparing the black dots there with the wiggly line that is what one would expect from the River Tord. So we can start to make an estimate. We can start to see what might have happened to this river. Now, that's just one example of a scientist making a prediction about something in the light of limited information and uncertain information. And it's pretty, I would say it's a pretty uncertain science, this, but it's good enough. And in fact, I went on to start to look at the factors in the urban area that actually caused this amount of erosion, and was reasonably successful in trying to sort some of those out. Now, I've also been operating, as Adam said, in other contexts, in trying to find out what has been going on in our rivers and our canals and on our beaches. I've been involved in the case against the water companies for sewage pollution. I put this up, and Adam will perhaps laugh here because I've said this before. This is the highlight of my career, actually, which is a headline in the Sun newspaper. But this is something that's attracted a lot of public interest. Sewage is spilling into English rivers, we would allege, and indeed this picture testifies to that, as does a lot of citizen science, actually, that's going on at the moment. So we started to look at trying to work out the amount of sewage spills into rivers. The court case is ongoing at the moment, so I can't give you a conclusion on that. But what we're basically saying is that water companies have underreported sewage spills into rivers. And we'll see how that progresses in due course. It might take some years. But we've been using a mathematical model to attempt to predict the amount of sewage spills that have actually happened, comparing those with the amount that have actually been reported. So again, it's the same question. It's how do you know what might have happened? And in this case, this is one which people are very angry about, actually. The amount of press reporting, not only in the Sun, but in a lot of other newspapers as well, and on the radio, has been very considerable. And there's a lot of public support for legal action in this case. I like this one. This was a conference in Brighton at the end of last year, when there was a lot of public protest outside the conference centre. And in fact, in the inset photograph at the top, I think that was in Birmingham around about the same time. So it's something in which there's a lot of public interest. Now, what we're trying to establish in that case is, how do we know what might have happened? What lawyers call the counterfactual. Now, I want to just give you another couple of very brief examples before I get into the thing that interests most of you, which is the murders. The counterfactual. This is an example of some research done by Professor Peter Hammond, who is an amazing scientist. And if you look at the blue line on this graph, it shows you over the course of August 2022, the proportion of flow, storm flow, coming out of, this is treated effluent actually, coming out of a sewage treatment plant, draining into Grasmere. The Lake District has attracted, as everybody will know, I think, quite a lot of interest in terms of water quality, particularly around Windermere. But this is Grasmere, and you can see there the flow percentage as a percentage of the storm overflow rate. And you can see there's a wiggly line going along there, running at around 70%. And then towards the right-hand side of the diagram, on the 22nd, 23rd of August, you can see that the flow rate exceeded the threshold capacity. So there's probably a spill going on there. But what I want you to look at is the bit in the middle, because some of the government agencies have the responsibility of sampling water from this treatment plant, and they came along to sample. And they came along to sample on either the 11th, I think, or the 12th of August 2022. And what did they find? They found that there was no flow at all coming out of the sewage treatment plant. So there'd been lots of flow in the run up to it, and there was that date, and lots of flow in the run after that date. But actually on that date, there was no flow. And so what is recorded is effectively a pass. They have passed the quality threshold because there is no flow. Now, if I look at that diagram, I think something is amiss with this. I make the assumption that actually there was flow, or there should have been flow, but it was turned off at the time when the sampling might have been done. Now that's, if you like, a counterfactual in legal terms. One can only speculate as to what the reason for turning it off might be, or what the results of that water quality sampling might have been. And here's another example, slightly different. This is January 2020. And what I'm asking you to look at here is the red lines. This is effectively the same parameter, this percentage of the flow, a percentage of the, if you like, the maximum flow. And you can see, as on the red line, particularly towards the left-hand side and the extreme right, that the flow is going above the threshold every day. At a particular time of day, it's popping above the threshold over and over again. Now, again, that's a daily spilling of raw sewage, and one has to, again, give some thought to why that might be happening, what the sort of counterfactual is on this. I won't go through the whole of the rest of the diagram, because I'm sure you're more interested in hearing about bloodier matters. But again, it's trying to establish what might have happened in this particular case in terms of spills, in this case, spills of sewage. Okay, so this is a matter which people say is about expertise. And I started off, I didn't have any particular expertise in this area of murders. I got into it because I was giving evidence at a public inquiry concerned with actually sand and gravel. I think it was in Leamington, sand and gravel exploration. And I was talking about the potential impact of making a large hole in the ground on the level of groundwater in the area, level in the ground, groundwater surface in the ground. And after I'd given my evidence, the inquiry ended for the day, and a man came up to me and he said, do you know anything about bodies in rivers? And I said, well, I know a little bit about it because I used to teach my students something about the flow of water in rivers by putting a few of them into wetsuits and floating them down the middle reaches of the River Severn with a life jacket on, and the rest of us would watch to see what happens. And that's how I started them thinking about fluid dynamics. So I told him this, and I'll show you the imagery relating to what he asked me in a minute or two. But as a result of that rather odd circumstance, I started to get involved in murders. Now, if we were in a live meeting, I'd be saying to you that not to worry about laughing, because murders are serious business. Somebody has died. And in fact, they're not all murders. Some of them may be suicides, and they're very sad. But sometimes murderers are very, very stupid. And I just put this one up. This was not one with which I had any involvement, actually, but this was somebody who, a man who murdered his son-in-law, I think it was, no, his adopted son, that's right. and then wrapped the body up in a carpet and put it in the boot of his car and drove to the south bank of the River Thames, as you can see here. And he parked the car, and then a police car pulled alongside him. And he obviously got in a panic, and the policeman got out and said to him, excuse me, sir, do you know why we've stopped you? And this man said, well, I've got a body in the car, he said in a panic. And the policeman said to him, ha, 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 sir, yes, perhaps, but decided to have a look anyway. And indeed, there was a body rolled up in the boot of the car in a carpet. And then the policeman said to him, well, actually, we only stopped you because you've got a broken tail light on your car. So I can't hear you laughing, but if you are, please be aware that although murders are a serious business, you are permitted to have the odd smile, and I sometimes do as well. Right, now, this is the case. This is a very early case that I looked at, very simple case, actually. This is an area some of you may know in London at Camden Lock. It's just near the Camden Market. And where you see the image of the flower, the police, the Metropolitan Police Serious Crime Group, found a body in the canal. It was vertical, actually, a male body, vertically, sort of caught on a ledge in the canal. And they wanted to know where the man might have come from in a very short period. I think it was actually only from the previous day. And I attempted, well, I came and looked at the site, and what you may not realize is, although I believe there are people from the River and Canal Trust on listening in today, but water does move through canal systems, in this case from west to east, left-hand side to the right-hand side of the slide. And I started to take some measurements of the velocity of the water, and it was very, very slow. And in fact, it was too slow for the equipment that I had with me at the time to actually measure. So I had to resort to using some dye in the water, some biodegradable dye. So I dyed the water, first of all, blue, and recorded the movement of this water through the canal over quite a short distance. And then I had another go with a yellow dye. It was the whole thing turned into something rather surreal, because along the bank of the canal, there were a large number of people who I assume were drug addicts, and who behaved very oddly when, first of all, the water went bright blue and then bright yellow. I think they must have wondered what was going on. But I did manage to measure the velocity of the water, and you can see here the results of my observations. And in fact, we established that the body had only moved a very short distance from just to the left of the road bridge there, and then had been caught in an eddy and lodged on the side of the canal. Now, this particular case, very simple indeed, and actually not a murder at all, probably. The chap was extremely drunk and had appeared to have fallen into the canal. So no, in this case, no evidence actually of foul play, but he might have been pushed, who knows, but I don't have to comment on that. So that was a very simple case. Now, are there a lot of these kind of cases? Well, actually, the truth of the matter is we don't really know. This is a graph showing the number of homicides in England over the period since 1960. You can see when people talk about the good old times, actually it wasn't so good. Murder rates were rising in the last 40 years of the 20th century. There was a peak in about 2002, but partly created by the murders from Dr. Harold Shipman, who murdered a lot of his patients. And they've been more or less falling since then. They're not back to the levels of the 1960s, but then our population is not back to the level of the 1960s either. So we see here around 600 murders a year, and I can't tell you how many of those end up with bodies in rivers, but some certainly do. Where do they take place? Well, the last analysis I've seen is for well, it would be for last year. The most murderous place in 2023-4 was Cleveland, followed closely by Derbyshire, Lincolnshire, and Gloucestershire, which always seemed to me rather unlikely. London is fairly near the top, and you know, some of the leafier suburbs are, as you might expect, lower down. But why that particular pattern exists, I can't tell you. The last time I saw this properly mapped was in 2018, which is a while ago, and you can see there's a very scattered pattern here. The darker colours have the most homicides, and the West Midlands has quite a lot. I live in Stratford-upon-Avon, but Stratford-upon-Avon is a genuinely leafy suburb for the most part. And again, back in 2015, I just would mention Boston in Lincolnshire, which seems like an unlikely place to be the murder capital of England and Wales, but actually had the highest per person rate in England. And in fact, I have had 2 inquiries in Boston in Lincolnshire, which suggests that, and one of them I'll show you, or some rather close to Boston, I'll show you. A third one actually close to Boston I will show you. But yeah, so 2 murders and 8 attempted murders in quite a short period of time, actually. Now, I want to come back to this case that I was first asked about when I was sitting in my public inquiry, and what happened. I said to the policeman, yes, I put students in rivers. I should add, I'd never lost one, and the students had a pretty good grasp of fluid dynamics by the time we'd finished. I wrote my fax number. This is a long time ago. Wrote my fax number on a piece of paper, and there we see the results of what arrived on the fax machine in the university the next day. And you can see there it's addressed to me, and it says, about our body found in the River Thames. 1, when can you start? 2, how long would it would take? 3, what will it cost? And 4, do I need to know the weight of the body? Now, what you might notice on here is it doesn't actually tell me what they want to know. So I had to make my own assumption about what they wanted to know, which was that they'd found a body in the River Thames, and they wanted to know where it might have come from in a particular time period. So what I have to do is assemble some evidence, and there's evidence of all sorts of different types. You can see here the length of the river, and you can see here again who uses fax machines these days, except I think hospitals sometimes. You can see here evidence about the flow rates in the River Thames at various places. And from this, I was working out the velocity of water in the river. And from that, how far the body might have come in a particular time period. And in fact, it had probably come from somewhere up above Boveney Lock on the left-hand side of that map, the western side of the map there, and found by a group of rowers, actually, which must have been a pretty nasty shock. Now, again, one of the things you have to deal with is witness statements, and here you can see the sort of thing which people say. Again, I'm not going to read all of these out, but what you will notice in the middle one is somebody from the underwater search team, who have a very difficult job, and it is very difficult for them to find bodies in rivers, particularly if they're in flood, and I will talk about that, an example of that in a minute. But you'll see that riverbeds are covered in our major rivers in scaffolding poles, car parks, fridges, shopping trolleys, and things like fire extinguishers, in my experience as well. So the riverbeds are kind of rough, and bodies can get caught on the river, on the riverbed. But the calculations that I make assume the bodies haven't been caught. So if we found a body, and I'm making an estimate of how far it might have come, that is assuming that it hasn't actually been caught on anything. So I'm giving the maximum distance it might have come. And this is the sort of thing that you get afterwards. You appear as a witness in court. This is a different case, which I'll come to at the end of my talk. Presenting a case in court, presenting evidence in a way that can be understood by a jury of non-specialists. So what we have then is a body entering a water and sinking, either thrown in or fallen in, or in some cases jumping in. And the body initially sinks to the bed of the river pretty quickly, usually, in amongst the shopping trolleys. And then it sits there and the water gets to work on it. Now, this is becoming uncomfortable, of course. Bodies deteriorate, and they deteriorate at a rate which varies with the temperature, actually. I've put in here the timescale typically for the UK, but the bit in red is the important bit. So after a period of time in the water, in the event of a body which is whole, i.e. doesn't have any punctures in it, there will be gas forming in the abdomen, and that will start to lift the body off the bed of the river. Now, if there's a flood, the body may in fact lift more easily than that, because it works rather like an airplane wing. The flow of water, the speed of water can lift the body off the bed of the river and carry it on down. Now, I'm going to look at a particular case, in this case not in a river, in a canal in Birmingham, and the body was in pieces in 2 suitcases. Pretty horrible, as my husband said, not likely to be suicide then. This is the canal, and the body was found by some workers trapped in some reeds a bit further down the canal from here. But this is the sort of thing we're looking at. And there's the suitcase there, one of the suitcases. So one suitcase was found in the lower right-hand side of this diagram. So the eastern end of the canal as it runs into Birmingham. And there were a number of witness statements from people who said they'd seen this suitcase. And I've posted them on particular locations to show where they to where they relate. And the last one was up here, which was on the where the I think it was somewhere near Brass House Lane. Well, no, just to the right of there, actually, the yellow pin there, assumed entry point. This is in 2014, and it was the end of April. So we're tracing back, and I started to look at travel distances, and here we see at the right-hand side of the diagram, the lower point, where the body, the suitcase with some body parts in it was found. And then if you track back different dates, you can start to make an assumption about the travel distance that the suitcase had come. Now, I should say that this part of the suitcase had the torso in it, and it was buoyant. The torso was filled with gas, and the suitcase was buoyant. The rest of the body, in the arms and legs and head, in fact, were found in another suitcase eventually at where I had suggested and looking at the flow of water in the canal as well, where the body had gone into the river. The first suitcase had gone into the river. So we can see here that over a course of a few days, the suitcase had floated down the river, and it had floated approaching 3.5 kilometers actually down the river. It had been helped along by little surges of water. Now, there weren't any measurements of flow of water in the canal, but there were some in adjacent rivers, near rivers. And you can see here the flow of water in 2 rivers and little surges, little pushes of little floods coming through in response to rainfall, pushing that suitcase along, giving a little push of water, and albeit slowly, the suitcase floats, first of all goes to the bottom, and then after it becomes buoyant, starts to move along the canal towards the point at which it was found some days later. There's some rainfall figures one has to analyze, but again, I'm not going to talk about those. And we can also look at wind speed and direction, wind speed in red on this diagram, and the bearing of the wind in blue. And you can see roughly around the time of the body had entered the river, or some days before, in the middle of this diagram, wind speeds, wind directions actually from the north, and then switching to the south. And in fact, what the effect of this was that when the body in the suitcase first entered the water, the wind direction, when it started floating, the wind had pushed it up against that that lock gate that I showed you. And it was only when the wind started reversing and the flow, the little pushes of water from the rain started moving it along, the wind speed switching to the south and west, that it actually moved along to the point at which it was found. So that's an example of the type of information one might use. It was a warm period. You can see here the average temperatures for that period around between 10 and 12 degrees. That's, as a daily average, is quite high. So the decay process was quite rapid, and the bloating and the gas appeared quite quickly. So there we have it. And if you just would like to watch this, after when we had worked out where the body might have started, if you look at this video, the police then analysed some video. And if you look at the top right of the image from a camera, you can see there two people pulling two suitcases along. That was in the evening, and then in the early hours of the morning, there they are coming back, but without the suitcases. And the police also found the second suitcase in the canal, around about the place where the first one might have come from as well. So I was able to give the police some help in sorting out this murder. Now, sometimes they're not murders. That one clearly was. Just an example of a very short example here of a person who went missing in the River Ouse in York. And this is a map showing the black dot in the middle shows where the person went missing. Now, there is a bit of a story to this one. I don't have too long to talk about it, but this person was extremely drunk and was with another person as a woman, and she'd met a young man. The two of them retired to the banks of the River Ouse to have a drink, and he said that she had slipped into the river in her winter coat. It was August, which seems a bit unlikely, but he said he got into the river, tried to pull her out. He couldn't lift her out. She floated away, or floated out into the river. So he went and got a train to Southampton. Now, I can almost hear the slight sniggering coming through here about this case. The point about this is the River Ouse has big floods in it. People will be aware of this from the news, I'm sure. And there were a series of major events in this which were sufficient to move the body some considerable distance, but also to make it very difficult for the police to search for the body at the point at which this young man said that this woman had slipped into the water. In fact, as she slipped in, the river level was already rising, if you analyze the flow, and made it very difficult to do the investigation at all. River flow, river is very powerful. River water is very powerful. If it's flowing at over about a meter per second, and this is flow, not velocity, but if it's moving at a rate of over about a meter per second, you can't stand up in it if it's over about knee deep. So it gives you some indication of the power of the water. So there we are. It lifts into the river and gets dragged along in the flow, in flood flow in that particular case. So the way I have to approach this is I start to try and model the flow in the river from Environment Agency data, and I survey the river at low flow when I go to do my investigation. Then I have to establish the roughness of the channel. Again, I don't have time to go through this in great detail, but from that we can start to estimate the velocity actually at the time of the event. And we use something called Manning's equation. If there are any geomorphologists amongst you, you'll be very familiar with this. And we established that the water velocity was low, but in this particular case, but it's probably sufficient to carry the body away quite quickly before anybody started looking for her. So, and she was actually found or disappeared towards the top of this satellite image, and was found some years later, actually, a long way downstream, 7 miles or so downstream. Okay, now let me give you another example of another type of investigation, again in a canal. This one is very different as an investigation. It's, again, we see here a canal, a body found, and the body was in parts, and it was on the bed of the canal. Now, what happened first of all was a walker found a human torso on the banks of the stream, there where the blue tent is. The canal was muddy banks, and the body was in there. And the police had to undertake a search for the rest of the body. So we only had the torso in this case. And they had to drain down the canal, which is very expensive and potentially quite damaging to the canal. But then they started to really earn their money. We'll see that in a second. But what they can do when you find a body, particularly in clothing, people analyze things like the pollen and diatoms, freshwater or saltwater diatoms, pollen, to analyze where the body might have been before the person died, because particular plants have particular types of pollen and so on. And in this particular case, bone reconstruction was done by the University of Warwick, and they ascertained that the body had been sawn up. Look away, because insect infestation can also be used to see whether the body's been exposed to air. Now, here's the police really earning their money. I'm not sure I'd like to be doing this, but this is where they managed to identify the body parts, find and identify the body parts, but they couldn't actually find a head, and they needed the head to identify the teeth, which obviously helped to identify who the person was. And you can see there, body part, truly shocking pictures. When I started looking at this, we started to look at this various things here. Were the locks open and shut any particular unusual amount and so on, which was not the case. And we did some stuff estimating flows. But the main thing that I did in this particular case was experimenting with some model heads, because we wanted to find out whether the head had ever been there in the bed of the canal, and whether it might have been washed away by moving water, because it sticks up from the bed of the canal a bit further than most of the other parts. In fact, so we did some experiments with some model heads on thin filaments, and we opened and shut the lock gate to see if we could get surges of water through to move the head. We had a head the right size and weight that my lab technician made up. We couldn't get it to move. So from that, we conclude the head was never there, and the police switched their search tactics to the area around it, and then actually found the head in a drain somewhere on the banks of the canal. So that was, again, it's a different kind of investigation, but the body, as I say, put into the river. This particular into the canal. This particular one, again, the story is shocking, and both shocking and funny, because the body was not reported, or when they found out who it was, I'm sorry, the person had been reported missing by his girlfriend. The body had been sawn up using a circular saw, in fact, and some weeks, or actually some months later, when the police were still investigating this, they re-interviewed the man's girlfriend, and she was living with his best friend who worked in a sawmill. So you can probably put together your own assumptions there about what had happened in that instance. Right, so that's a different kind of investigation. This is another alternative way of measuring. This is near Boston, again in Lincolnshire, a body found in an artificial channel, in a drainage channel in the fens, on the top right of the diagram there, of this image there. Body found and picked out by an automatic trash removal system in front of the pump that takes water from the low level in the Hammond Beck and pumps it up into the southern 40-foot drain, and then from when it goes out to sea in the Wash. And the body had moved along and fetched up against the inlet of the pump and then been fished out by an automatic trash removal system. I managed to work out again where it might have come from in this particular channel. You can see the trash screen there at the bottom of the picture, and we can, in this particular case, I had no flow records, but we did manage to get the pump operations, and we, using the number of times the pump went on and off and the volume of the pump, we could work out the water velocity through the drainage system and work out the maximum distance. This particular body was a man, a Polish man who had been tortured, in fact, before being thrown into the water. Managed to work out where he had entered the water, where his body had entered the water. Little digression, and then I'll give you a last example, very brief, 2 examples actually. I had again, I won't spend too long on this, but I had a forensic hydrology encounter with the law in a case in King's Winford, when a man wanted to establish that his house was being flooded, his house being where the red arrow is, by operations from one of the water companies, who he said had a leak under his house. And when I started looking at this, I couldn't find out where this water that was welling up in his garden was coming from, but I did find out on early Ordnance Survey maps a series of ponds. His house is near the top red circle, a series of ponds and springs and so on, associated with, as it turned out, the western boundary fault of the Southern Staffs coalfield. So in fact, my suggestion to him was that this was not a leak from a water pipe, and we did do some water chemistry as well. It was not a leak from a water pipe, but was a groundwater spring associated with the fault. The man didn't like this. Sorry, that's just the Environment Agency flood map. The man didn't like that conclusion and decided he wasn't going to pay me, so I had to take him to court to get the money back, which was a bit of a challenge. Now, very quickly up to date. Just last week, some of you might have seen the case of the paddleboarders in the Western Cleddau in Haverfordwest, and somebody actually admitted guilty to taking a group of paddleboarders down this river from the bridge you see on the right, over the weir, down to the lower part of the river, which was tidal, and she and 4 of them drowned. It was a very sad, extremely sad case. The woman who was leading this group has pleaded guilty to a manslaughter charge, and has yet to be sentenced, in fact. But what I was able to do was to work out the amount of water going over that weir. Now, in August, she did a reconnaissance in August. This is some years ago. The wheels of the law roll very slowly. In August, when she went out, the river level going over the weir was very low. You can see there how low it was. The spiky bits are where the tide comes up and over the weir to the river level monitoring point. So at that time, the tide was low and the river level was low. If you look at the conversely, the period when she took them out, which was in October, remember she'd done the reconnaissance in August, she took them out during, again, a point where the tides were not overtopping the weir, not coming up over the weir, but the amount of water going over the weir was very considerable. So there's nearly a metre of water going over that weir. And that was sufficient in combination with a low tide below the weir to give a big drop over that weir, over which, sadly, the members of this paddleboard excursion fell, and subsequently, as I say, four of them drowned. So that's another example of, if you like, finding out what might have happened from forensic hydrology. Now, I just want to give you my last example, and then I'll pause for questions. This is, I think, my favourite case. It's just near Great Yarmouth, and a body was found, as you can see there, on a huge meander on the River Bure, a tidal river in Norfolk. In fact, it was found at a time which was the highest, or the day after the highest tide of the year, a spring tide. And it made it very difficult to work out what had actually happened in this instance. There was simply not enough information to compare with the night in question. So we had to wait for 6 months until the next very high tide in the autumn. And then we did some experimentation with some dummies. So I was reconstructing the tidal cycle at the site of discovery. This is water coming up the River Bure from the coast. In fact, the flood peak travels faster than the water itself for reasons, it's like a shock wave. And I actually wanted the speed of the water itself, which is a bit more complicated to work out. But let me just show you how we did it.
No problem about that. I've done that years.
So here we can see we had a couple of dummies made, which we released at different points in the river, and we managed to get one of them to ground at the point at which the actual body was found.
58.47 for the 6th marker post.
58.47.
So you can see that the dummies floating upstream, and it landed where we've got scene of the crime marked. And from the timing of that, I was able to work out the time and roughly the location at which this body had been released, much further down the river, Tarworks Road, as you see there on the map. Again, very high tide, and from that, the police managed to find CCTV footage of this incident. It was a young woman, a young female asylum seeker who was murdered, actually, and her body thrown in the river. And I have to tell you, folks, that it turned out to be the husband who did it, as sadly is often the case. And he was found guilty. This is a long time ago now. He was found guilty and sentenced to life imprisonment. So that's just a brief set of examples trying to illustrate for you how forensic hydrology can be used to assist the police with their inquiries, and the variety of scientific methods that one might use to tackle that kind of problem. So if you have been, thank you very much for listening, and I'll now pass you back to Adam.
Thank you, Carolyn. Always interesting to hear someone applying discipline knowledge in a very novel context. And I'm sure you've either inspired some other scientists to get involved in forensics. Let's hope that, rather than inspiring any murderers to be able to cover up their tracks. I've not had any questions through. You can post them in the Q&A if you've got any questions for Carolyn. We've only got a few minutes left, so I can probably only take one question. One question from my perspective is, I presume it's quite important for the police to be recording the right data when they find a body or lost one, and would save you a lot of work in going back looking through meteorological and flow rate records. Have the police got a good understanding of the science around this, and are they kind of giving you the information that they want in the same way that they might do with other kind of types of forensics, when they would make sure that they wouldn't be touching the scene? Are they actually recording any data for you?
It's a very good question, that, and the answer often is no. And actually, when I've done these cases, I've very rarely been brought in shortly after the crime or apparent crime has been created. So often there's months, if not years, has gone past before I get called in. So then you're reliant very heavily on what you can get from various authorities, what you might be able to reconstruct. I would say that the police, I mean, I don't think hydrology forms part of it, let's say, a forensics degree course. I think it should, and I think that would improve the situation a lot. But I mean, I've been given examples. I could give examples where I've been given the wrong location, for example, of the body, some hundreds of meters out on a map as to where the body was actually found, and that makes a big difference, of course. So issues around precision and so on are important. Yeah.
Okay. 5 questions have suddenly popped up, so we'd have to have quite quick answers to get through these. So 2 of the questions cover the same thing, really, which is about how do you get into this? What's the kind of educational background, and what advice would you give someone to get into forensic hydrology?
Well, yes, there's an open door now, because I've taken my name off the list because I'm getting too old for this kind of thing. I think the Haverfordwest thing was the worst, because I had to get in full safety equipment and it was dreadful. So I've actually stopped doing it now. So, and as far as I know, actually almost nobody's doing it. Yes, you could get into it. I got into it by happenstance, but I would say what you needed is a good general science background, and an inquiring mind, and an ability to think outside the box as to what kind of evidence that you might be able to pull into to solving these cases, because it isn't always obvious. Like, for example, the case in Boston, where I had to use effectively the pumping records rather than anything to do with the river flow. Just in fact, to start off with, I used the record of the electricity pulled in to drive the pumps to get indirectly the volume of water, and from that to the speed of the water moving through the drainage channels. So yeah, an inquiring mind. And as I was a physical geographer. That's how I started my career. But actually what I was doing would now be called environmental science, as you know, Adam.
There are some other questions, but I'm afraid we've run out of time. So unfortunately, we can't get to those. I hope you've enjoyed today's discussion. If it sparked your interest, you can watch a longer version of this talk, which was given at last December's IS Burntwood lecture. That's available on the IS YouTube channel. This and all the other talks hosted by the Science Council as part of British Science Week will be appearing on the Science Council YouTube channel next week. It is not too late to sign up for the final talk in the series tomorrow, which will be on the responsible handover of AI. Tickets can be booked through the Science Council website. And finally, it's 1 o'clock. My thanks go to Professor Carolyn Roberts for a fascinating talk, the Science Council for hosting, and for the audience participation. Thank you for your questions.
Thank you, Adam.